So looking at point-to-point VPNs, they're very similar between the ASA and firepower. A lot of the same configuration requirements are going to be necessary regardless of which platform that you choose to deploy on. We'll go through and look at some of the differences between the two. First off, just contrasting IPsec VPN support. The Cisco ASA supports cryptomaps as well as VTI-based IPsec, where firepower really just supports the cryptomap-based IPsec. When we look at management options, the ASA gives us ASDM or the CLI for our typical configuration capabilities. And then, of course, with firepower, we've got FDM or Firepower Device Manager for smaller deployments, and then FMC, where we have a dedicated management platform for larger deployments. The Cisco ASA IPsec VPN supports both IKEv1 as well as IKEv2. If you're deploying everything brand new, it's a brand new company, we've got all brand new equipment running the latest, greatest code, sure, we would just go with IKEv2. But anytime we require backwards compatibility, maybe with some older equipment, that IKEv1 support is really nice to have. It'll be found on the firepower devices as well. Digital certificates as well as pre-shared keys can be supported for authentication. And remember that IKEv2 has the capability to support hybrid or asymmetric authentication, meaning we can mix and match what we want to use between two different parties. The routing support, of course, includes static routing, as you might imagine, but also something called reverse route injection, or RRI. Reverse route injection can be a little bit intimidating at first, but it's really useful in scenarios specifically like remote access VPN. Imagine we've got a remote access VPN client that's coming in remotely. When that client connects in from the outside, there can be a redirect to a different ASA that has a lighter load. So let's say at one point, this remote access client connects, and it goes ahead and it lands, let's call each of these units A, B, and C. It lands on unit A accepts a connection and is the active forwarder. When this remote access user authenticates, based on their AAA profile, they're assigned an IP address. Now you can do this to make sure that the same user gets the same IP each and every time. It's neat for logging. So let's say something like this occurs. We assign this IP address to this user. Now, while they're communicating with the network, maybe they're at a remote access, maybe they're off-site, they're at a hotel, and the Wi-Fi is not that great. So they lose their connection and they drop, and then they have to reconnect. When they reconnect, they hit A again. A, having load information about B and C, says, you know what, actually C has a lighter load. So the second time that they come back, the connection has been redirected here. So the way that this impacts the internal network is what's happening to the right of these routers. Is it all one common subnet? Is it all a common broadcast domain? Or do we have independent hops between them? See, depending on how complex the internal environment is, if there's a resource, and that resource needs to get back to whatever IP address it is that we assign the user, which gateway should we use to get there? A, B, or C? It's like one of those games where they hide something under a cup and then they move the cups around rapidly and you're supposed to guess where it's at. How do we know where our remote access VPN users are? Well, this concept of reverse route injection is the ability for whoever's providing remote access. These are our edge devices, sometimes called a head end. The head end will advertise the presence of this particular user. So if we have that user connected to us, we advertise leveraging maybe OSPF or EIGRP, just doing a route advertisement, a host route /32 to the inside of our environment. That information will be propagated throughout the rest of the routing domain. So everyone knows how to reach these remote users, even when their connectivity might be limited, right? If we think about people that are in cars, planes, trains, they could drop off and come back at any time. And if they do that, well, if we're doing load sharing across multiple devices, there's a good chance they could land on a different device. RRI helps the internal environment adapt to that. Additionally, we've got a proprietary OSPF over crypto maps based on IPsec VPN. So we can still rig it up so that OSPF works. Additionally, ASA in the recent years was granted access to the BGP protocol. So most customers aren't going to require BGP on their ASA. They're not typically using this as an edge device, pulling full tables, applying policies, but this can be used for custom architecture of our routes and architecting more complex or more intelligent solutions than maybe we were using previously. So for customers that require BGP, realize that it is supported on the ASA now. Looking at Cisco's Firepower Next Generation Firewall, it also has support for IKEv1 and IKEv2. Now, Firepower was around for a while, and we were deploying it on top of Cisco without any VPN support. Once it was added, I was a little surprised to see that it has IKEv1 as well as version 2. Because version 2 had been in production for a while before this came out, so I said, it's really nice that they added that backwards compatibility. Again, maybe we upgraded the firewalls at our data center, but maybe we've got a lot of equipment out there in the field, maybe at warehouses, maybe at branch offices that's a bit older. It's nice to know that Firepower's got support for both the older generation, version 1, as well as the newer generation, version 2. Additionally, when we look at authentication, we have support for pre-shared keys, which is quick and easy, and then digital certificates, which again are considered to be more secure. Now, in terms of routing with our VPN, at the time of this production, the routing support is really just static routing along with reverse route injection. So some things to consider, for as far as access control, typically when we bring up a VPN, we grant that user access to everything in the organization. Is that true? Depends. But by default, we don't have anything to limit their access control. But that doesn't mean that we can't. Especially with things like remote access. We can push down a firewall policy to a remote user that defines what they're allowed to access and what they're not allowed to access. So things to consider. Should we just let everything through, or should we try to lock it down? Additionally, would it be appropriate to NAT traffic that's going to go through the firewall? I mean, think about it. If we've got an office on the left, and I'll just go again with 10.1.1.0, we've got something on the right, 10.2.2.0, and I might have a NAT policy on my outside interface. So if I say IPNAT inside, IPNAT outside, and my NAT policy says NAT everything, I would NAT packets as they're about to be encapsulated, because maybe it's associated with a crypto map on an outside interface. It's probably not something I want to do. So what we could do is actually create a NAT exemption. If you're NATing based on an ACL, we could deny traffic going from 10.1.1.1 to 10.1.1.0 to 10.2.2.0. And then we would permit 10.1.1.0 going everywhere else. So basically deny the VPN traffic, and then we would permit the rest. And a lot of people get confused by that because they think that they're going to filter traffic. Remember, ACL is a selector. The permit means take the action. We can use ACLs to encrypt. We can use ACLs to NAT. We can use ACLs to rate limit. So you're just saying, hey, firewall, when you see packets that match this flow, do this to them. Maybe NAT it or handle it differently. If it's policy-based routing, we would route it differently. Additionally, things to consider, routing. Is there a route for the remote network? Of course there is. Okay, is it pointing to the appropriate interface? If it isn't, you'll never hit that crypto map, which means you'll never be encrypted. Or if you're using virtual tunnel interfaces, if you're not steering the remote office traffic into that tunnel interface, well, we'd never have a reason to bring up a tunnel.